Okay. Before we begin, let's try to recap what we talked about last time. Okay, so in this case, in these 2 weeks, and I think also in the next week, the next upcoming week, we are going to talk about sequence and series a lot. Okay, so what is sequence? Sequence is just if you have, this is the brace notation. This is called brace notation. Okay, so we have something like this. Kenapa tiba-tiba dah pula jadi macam ni? Dia tiba-tiba mati pula. Dia punya ni. Okay, macam tak boleh dengar. Boleh dengar ke? Sebab dia tak naik.
Boleh, doktor.
So apa tadi? Sequence. So this is just a list of numbers, positive integers. So n is positive integers. Sometimes it can start from 0. In most cases, it starts with 1 and equals to 1 until positive infinity. So you can have something like this: 1, 2, 3, 4, and so on. So this is like the series will be the series notation. The formula for the series is just n plus 1. So n start from 0 until positive infinity. You can also have even number series, 2, 4, 6, and 8. You can also have a fractional series. For example, I have 1 over 2, 1 over 3, and until goes to infinity. This goes into infinity. Okay, so this is just the sequence. We also talk about the converging sequence and diverging sequence. So if a series is converge, what does it mean? If its series is diverge, what does it mean? Okay, so if you take the limit as n goes to positive infinity, a of n, this goes to a single value L. Okay, otherwise the series is, this is converge, series, and otherwise it will be diverges. Okay, so I just draw an example. This is called converging and diverging nozzle. You can see this in most space rocket, something like that. So this is the value when the values goes to a single value right here in the middle at the throat, and then at some point might be the series goes to in every direction. So this is converge, and then this is diverge. You can understand that converge meaning it goes to a single value. What happened if it's alternating series or maybe oscillating? Meaning that the values, when you take the limit as n goes to positive infinity, a of n, it has either minus L or positive L. So let's say this is if n equals to something, and then this is otherwise. Okay, so this is also diverging series because it doesn't goes to a single values. Okay, even though the value is the same, but the absolute value is the same, but the sign is different. An example can be if you have -1 to the power of n plus 1, for example. This is a diverging series. It doesn't goes to a single value. It doesn't goes to a unique value of L. We also talk about monotonicity of a series, which means that the series either increasing or the series can be decreasing. Okay, so increasing meaning that the subsequent term, so let's say is bigger than the previous term. So for example, if I have A1 is less than A2 is less than or equal, okay, equals to 2A3, and this is AN, for example. So if you have something like this is an increasing. But if you don't have the equal sign, let's say this is A1 less than A2 less than A3 and so on, this is strictly increasing. The same thing, otherwise, if I have A1 is much bigger or equal than A2, bigger or equal than A3, and so on, and the least one is AN, so meaning that the first term is bigger than the subsequent term and much bigger than the end of the term, so this is decreasing. Right, and then if you have same thing, if you have something like this without the equal value, this is strictly, this is called strictly decreasing. Okay, you can also understand this from graphing point of view. For example, if I have a parabola, something like this, okay, but if I take let's say this is the point right here is x equals to 0, so x from 0 to x equals to positive infinity, this is increasing, and then from minus infinity to 0, this is decreasing. You need to put the limit. You can also understand something like this, a graph of like that and like this and so on. You can also have, okay, and then we also talked last time about bounded and monotone. So if you have the function, not the function, the sequence, if the sequence is bounded and monotone, you can say that the sequence is converging. Okay, and if you have the sequence as unbounded, in the same category, monotone, this is called diverging series. Okay, in terms of this, we also, I think that I said this briefly. You can also have something like in this bounded, let's say I have A1, A2, and AN, okay, and then you have that you have that something at this boundaries on the the far left, right. So this is on the bigger. This is like let's say if I have in between some value. Okay, so this is like a scale, something like that. Okay, so we talk about least upper bound, least upper bound, and we also talk about greatest lower bound. Okay, what does it mean by this? Okay, so if you have something like this, let's say if an, the notation, I will talk about the notation. I don't want to talk about, I can talk. Okay. Let me see, hold on 1 second. Sebenarnya apa ni screen komputer saya ni dipecah, dia jadi ini sikit. Dia macam lembab sikit. Kejap sekejap saya ada technical issue kejap. Okay, so let's say if I have, let's say, let's use, this is like an in an is in A. Let's say this is M. This is M. The value right here is M. Saya ada gangguan sikit. Okay. Okay. Apa tadi? We have something like AM is the when AN is the last term in this sequence. Okay. Dan katakan there is ada satu lagi upper bound kat sini somewhere before M. So we can say this is big M. This is less or equals to M. Okay. So any value that is less than this. So kita kata this M prime is the supremum of A. So A is what? A is this, the whole thing. A is the set of A1 until AN. So the least upper bound, M prime is the supremum of A. Dia punya ni nama dia supremum. Okay, let's say, and we also have something, let's say on the left boundary, kalau tengok dekat left boundary ni, we have M, small m, the lower boundary. Dekat dengan kawasan lower boundaries ni, kita ada, we have somewhere close to small m. So let's say we have m is bigger or equals than small m prime. So small m prime ni dipanggil greatest lower bound. M prime is the infimum of A. So this is infimum. Okay, kalau apa maksudnya? Maksudnya kalau dia punya boundaries tu, contoh yang paling mudah kalau saya ada, let's say I have, this is my x in A to B. Okay, kalau saya faham macam ni, there was some value such that there exists, let's say maybe A star. Okay, there exists x in what? In apa? A prime dengan B prime. Okay, maksudnya dia termasuk dalam nilai dia punya nilai dia punya domain. Okay, so A prime is the infimum INF, the greatest lower bound, and then B prime is my supremum of X, the infimum of X. So somewhere dekat-dekat dengan dia punya boundaries. It can be less or it can be less or equal. It can be big or it can be big or equals. So this is the notation untuk apa? Untuk infimum dengan supremum. Okay, dan saya juga saya lupa nak cakap tentang ni, tentang satu lagi, namanya adalah Cauchy sequence. Okay, apa maksud Cauchy sequence? Yang ni orang French. Dia bukan Cauchy, dia adalah Cauchy sequence. Okay, kalau kita ada sequence, let's say I have a sequence of UN. I have my brace notation UN. This sequence is Cauchy sequence. If you have epsilon is bigger than 0, a small but positive value, there exists n such that n is natural number such that u of n minus u of m is less than epsilon. So you have m and n is a positive. Saya dah terbiasa tulis juga ni. So n is natural numbers. Okay, apa maksud apa dia punya ni? Apa dia punya kelebihan dekat Cauchy sequence ni? Kalau saya ada series and then if it's Cauchy sequence, then it's convergence. Good thing about this is the theorem which says that if the sequence is Cauchy sequence, then if and only if the Cauchy sequence, then we have converging sequence. Okay, proof ni saya tinggalkan untuk awak tengok. Okey, apa maksudnya? Kalau saya tengok dekat sini pun, kalau tengok dekat sini, Cauchy sequence dia adalah dia punya the next n, un is the last one, n tu dia minus and some values between n and mm. M can be bigger or n can be bigger. Dia boleh juga dia bigger or equal. Just like look at the boundary. Okay. And you can see that kalau dia beza dia, the difference of its absolute values is less than a small value epsilon. So maksudnya dia adalah Cauchy sequence. So yang ni kelebihan dia. Tetapi adakah sebaliknya betul? Maksudnya kalau saya pergi ke sini, adakah dia betul juga? Memang betul pun. Sebab apa? Sebab dia punya ada kat sini if and only if. So if and only if maksudnya kalau dia Cauchy sequence dia adalah converging. Kalau dia converging dia adalah Cauchy sequence. Sebab tu ada if and only if. Sekejap sebab ada orang masuk rumah jap. Okay, this is important note for E. Important note. Okay, E. So E ni kalau awak tengok dia punya nilai e to the power of 1. So this is in between 2 and 3. So the exponential E is the value between 2 and 3. Okay, so apa macam mana kita nak tengok? Macam mana dia dapatkan how did mathematician get this value? So if you have this series, 1 plus x to the power of n. Okay, 1 plus x to the power of n. Kita dah tahu benda ni this is bounded by 2 and 3, but before we go to this conclusion, there is some calculation before this. Okay, so how did we arrive at this conclusion? Okay, macam mana kita dapat? Okay, let's say first one, if you have this sequence 1 plus x to the power of n, so if you expand this, it will be so n start from 0. So n start from 0. You can have a series of exponential, not exponential, expanded multiplication. So if you expand this, you can have you can have 1 plus nx plus n times n minus 1 over 2 factorial. This is the Taylor series times x squared plus n times n minus 1 times n minus 2 divided by 3 factorial times x cubed plus something plus x to the power of n. Okay, so if n is 2, this is how actually the quadratic function, the cubic function expanded. I think you learned this in algebra. Saya tak pasti awak ada tak benda ni dalam algebra 3200. Tak pernah jumpa? Ada kan? Pernah jumpa kan?
Pernah.
Pernah. Saya rasa sampai n equals to 3 rasanya, yang n sampai infinity, sampai until n tu saya tak pernah tengok lah pula, tapi rasanya awak kena ingat formula dia sampai n minus 1, n minus 2, 3 factorial. Okay, so if I replace, I want to replace this series, x equals to 1 over n. Okay, apa jadi? Let's see what's happened. Okay, saya cuma replace saja, saya cuma ganti. So x is 1 over n. I get the first term 1. So yang ni tak ada masalah. So this one is still the same. Okay, and then plus n times 1 over n. So n times 1 over n. So dia akan, let's see, before that, dia akan jadi 1 plus 1 over n to the power of n. Okay. So dia akan jadi, this is multiply by 1 over n, so akan jadi 1. Because why? Because we have n times 1 over n. Okay, so you replace x by 1 over n. So dia akan jadi 1. And then just replace this term. So if you replace this term, it will be 1 over n squared. If you replace this term, it will be 1 over n cubed. And then the last term will be 1 over n to the power of n. Okay. So this is like the multiplication will be 1 over, this is like 1 over n to the power of n, the last term. Okay, so let's try to kita susun balik. So how does it looks like? So this looks like something plus n minus 1 to 2 factorial times 1 over n squared plus n times n minus 1, n minus 2 divided by 3 factorial times 1 over n cubed plus something 1 over n to the power of n. Okay, so kalau awak tengok kat sini, if you look at this, actually this one will be n factorial as well. Okay, so kalau awak tengok kat sini, dia akan jadi n factorial. Dia punya ni, n factorial bagi dengan n factorial. Sebab, why I say n factorial? Because this is n, n times n times n. Sometimes it's hard to explain. Okay, tak apalah. Just take my word for that. But you can see that this one is cancel out. Tak ada masalah. Okay, so kalau saya susun balik dia punya ni, dia akan jadi 1 plus 1 is 2. Saya nak buat 2 ke saya nak tinggalkan dalam bentuk tu? Rasa tak apa kot. Saya tinggalkan dalam bentuk 1 plus 1 je lah. Sebab saya tak nak ada, nanti dia senang nak nampak. Okay, ada 1 kat depan tu. Okay, so this is still 1 plus 1. Okay, plus, so saya expand kat sini, saya akan jadi take out the factorial, saya akan jadi 1 over 2 factorial times factorize yang ni, jadi n tolak 1 bahagi dengan n. So it will be n times n minus 1 divided by n squared. Okay, saya tulis sikit dulu, nanti saya akan jelaskan. Okay, so kalau yang ni, if I simplify this, I will get n minus 1 over n. Right, so I simplify this. Okay, then kalau saya simplify sekali lagi, if I simplify another one again, so this will be 1 over 1 over n. Okay, are you with me so far?
Yes, Doctor.
Okay. So something sama juga kalau saya buat macam ni. So this is 1 plus 1 over 3 factorial. Okay, 1 over 3 factorial. It will be n over n cubed times n minus 1, n minus 2. Okay, so kalau saya simplify this term, it will be 1 over n squared times n minus 1 times n minus 2. Okay. Kemudian kalau saya simplify lagi, so if I simplify it more, it will be, so it will be 1 over n. So 1 over n, it will be n minus 1. Okay, and then n times n minus 2 over n. Okay. And then what happened? If I divide this, it will be 1 minus 1 over n. And this one will be 1 minus 2 over n. Okay, so saya cuma distribute n squared. So saya distribute n squared to n minus 1 and then another n to n minus 2 and then simplify. Okay, kalau awak tengok dia macam ada nampak something like a pattern. Okay, dan kalau yang terakhir dia punya ni, dia akan jadi macam mana? So nampak tak dia ni 1 jadi 2, awak boleh tengok kemungkinan 1 tolak 1 per n darab 1 tolak 2 per n darab 1 tolak 3 per n. So dia punya last term, dia as if seolah-olah plus 1 over n factorial, okay, 1 over n factorial, let's say y, this is 0, 1, 2, 3, this is n factorial, times 1 minus 1 over n, this is the first term, dia akan multiply by 1 minus n minus 1 over n. So this is the last term in this case. Okay, so kita nak tengok dia punya ni. Kita nak tengok dia punya apa? Dia punya boundaries dia. Dia punya boundaries. Okay, so kalau saya kata, if I said that this value, kalau saya buat apa nama dia? Pernah dengar dia punya dalam algebra, U goes until k, and then it will also true for n1. So we can say test for n plus 1. Okay, apa maksudnya? Kalau saya buat ni, so maksudnya dia, kita nak letak dia punya apa ni? Dia punya conclusion. So true for k, and then it should also true for n plus 1. Okay, so kalau saya buat, so this one, if I said something like this, kalau saya kata this sequence 1 tambah 1, so 1 plus 1 plus 1 over 2 factorial times 1 minus 1 over n plus 1 over 3 times 1 minus 1 over n times 1 minus 2 over n plus something, and then the n term will be 1 over n factorial times 1 minus 1 over n times 1 minus n minus 1 over n. So this is multiplication. Ini bukan yang apa ni, yang macam yang ni adalah term. Kalau saya takut awak keliru je. Okay, so kalau saya kata this one is actually true, this is less than, tak muat. So this is less than 1 plus 1 plus 1 over 2 factorial, 1 minus 1 over n plus 1, okay, plus 1 over 3 factorial times 1 minus 1 over n plus 1 times 1 minus 2 over n plus 1. Okay, and then plus something, the rest. Okay, kenapa yang ni betul? Why is it like this? Why? Okay, sebab contohnya, let's say if I take example, satu tolak, let's say let n equals to 2. Okay, n equals to 2. Satu tolak, the rest is the same, but the only difference is this denominator. This is n, the denom is, this is n, and the denom is n plus 1. All other constants stay the same. So we need to figure out the boundaries. Okay, let's say n equals to 2, 1 per 2. 1 tolak 1 per 2. What's the relationship between if I say 1 minus 1 over 2 plus 1, 3. Okay, obviously yang ni adalah obviously 1 over this is berapa dia? 0.5. Okay. Yang ni apa dia? 2 per 3. So 0.5, or maybe I can just use it in fraction. 1 over 2 versus 1 at 2 over 3. Betul tak? 1 per 2 lebih kecil daripada 2 per 3. Separuh lebih kecil daripada 2 per 3. So sebab tu saya buat this is for extra n plus 1. If you add one more term, it will be bigger than the previous term. Okay, are you guys with me so far? So this is, kita ambil nombor yang mudah-mudah je untuk buat ni. Okay, kita tak nampak. Okay, so this is true from what I showed just now. Okay, so kalau ni, sebab dia adalah pecahan. This is a fraction. Okay, so what's this? So I can say that this is this term, this whole term. This thing is 1 plus 1 over n to the power of n. And this term, let's use a different color. Let's use yellow, I think. Okay, this term is what? This term is 1 plus 1 over n plus 1 to the power of n plus 1. And this is less than this one. Okay, so kalau kat sini, so what does it mean by this? So meaning that an is less than an plus 1. Apa maksud kalau saya tengok dari segi monotonicity, apa maksudnya? So meaning that this one is an increasing sequence. This is an increasing sequence. Sebab apa? Term yang berikutnya lebih besar daripada the previous term. Okay. Okay, so kalau saya, let's say, I can also approach this in another. Let's see, this is increasing monotonicity, decreasing sequence. So yang ni strictly increasing sequence. Okay, and then saya nak tengok dia punya bounded or not. Let's see, and then let's look at the boundaries. Okay, kalau tengok kat sini, we have one minus 1 over n, 1 minus 1 over n times this. Okay, so kita tak tahu n tu apa. So I need to take the boundaries or inequality for this term, 1 minus 1 over n, okay, times apa dia, mungkin saya tak boleh buat macam tu. Okay, saya kena 1 minus 2 over n times 1 minus 3 over n until 1 minus k over n. Okay. So if you look at this term, and then k is a positive integer, k is starting from 1 until n minus 1. Okay. Sebab apa? Sebab n minus 1, sebab the last term kat sini adalah n minus 1. So if you look at this one, this is k. Tak nampak. So k from, so this is your k, n minus 1. Okay, kita nak approximate, bukan nak approximate, kita nak take the inequality sebab kita nak tengok dia punya boundaries. Okay. If you look at this one, for any value of k over n, you can see that this one, this term, this multiplication is actually less than, this multiplication is less than 1. Sebab apa? Because let's say this one is, let's say n equals to, I cannot say less. Let's say if n equals to 2. No, this is, let's say n is a big number. Let's say if you have 2 terms, let's say n will be, that will be minus 1. Okay. So why? Because this one, this value is less than 1. Sebab dia adalah fraction. This value is also less than 1. And this is less than 1. Same thing for this one. Okay, contohnya kalau saya nak buat 1 tolak 1 per 2 darab dengan apa? 1 tolak apa ni? Bukan 2. 1 per 3, 1 tolak 1 per 4, 1 tolak 1 per 5, and so on. Contohnya macam ni lah. Okay, so this one is less than 1. It's also less than 1. This is also less than 1, and so on. So dia punya ni always less than 1. So in that case, kalau saya buat ni, saya buat conclusion bahawa this value is less than 1. So I can say something like this. I can say 1 over 1 plus 1 over n to the power of n. Okay, this is less than 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial and plus some until 1 over n factorial. Okay, so you can see that kenapa dia ni, why is it less than? Because of this assumption. Okay, why? Because this one is multiplied by n times n minus 1. No, n minus 1 yang kat sini tadi. Sorry, 1 over 1 minus 1. Apa dia tadi? 1 over 1 minus n. So this term is 1 over n. This term is less than 1. Okay, and then you have the multiplication for this. I have 1 minus 1 over n times 1 minus 2 over n, this term is less than 1, and so on. So sebab tu kita dapat conclusion yang this term, this whole thing is less than this. Okay, so you can also simplify. So kalau saya simplify benda ni, okay, saya simplify lagi, more simplification. I can say this is also less than 1 plus 1 plus 1 over 2, okay, plus 1 over 2 to the power of 2 plus 1 over 2 to the power of 3 plus 2 to the power of n minus 1. Okay, kenapa? Why? Okay, so kalau awak tengok kat sini, so if I said something like this, okay, let's look at this term. 1 over 3 factorial. 1 over 3 factorial versus 1 over 2 factorial. Mana lagi kecil? So this will be 3, this is like 3 times 2 equals to 6. This is 2 times 2 equals to 4. Okay, so obviously, if you compare this to that, okay, so yang ni lebih, this is, you can see that this is the same. But if you compare, this is same. If you compare the second one, okay, 1 over 6 is less than 1 over 4. Same thing, this one is 4 factorial. This is 4 factorial is 4 times 3, 12, 12 times 2, 24, and then this one is 8. So the same thing, you can see that this term is less than that. And you can go until 1 over n factorial. Boleh faham ke apa yang saya nak sampaikan ni? Okay. So kalau saya masukkan balik, so this is less than, this is 2 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. You can see that this term is less than 1. Okay, so in that case, kalau saya buat macam ni, so this term is less than 1, meaning that saya ni, so this is also term less than 2 plus something less than 1, this is less than 3. Okay, but if this term is less than 1, so this is in between 2 and 3. So in that case, you can see that 1 plus 1 over n to the power of n is somewhere in between 2 and 3. So meaning that, apa dia tadi? First thing is, you know that 1 over 1 plus n to the power of n is monotone, strictly monotone. And you also have the value is bounded. You can say this one equals to e. Let's say 1 plus 1 over n to the power of n is equals to e exponential. And then e is between 2 and 3, which is bounded. So this series 1 plus 1 over n to the power n is converges sequence. And if you take the limit as n goes to infinity, 1 plus 1 over n to the power of n equals to e. Okay, so that's what I mean by this one. So e is what? E is an irrational numbers. If you want to remember the decimal point, it's up to you if you want. Okay, any questions so far? Okay, so tak ada. Kalau tak ada, let's see this one. Let's see some example. Okay, if the limit, example, I have if the limit of n as goes to infinity for 1 over n, 1 plus 1 over n equals to e, and then show that the limit for n goes to infinity for 1 plus 1 over n plus 1 to the power of n is the same when limit 1 plus 1 over n, you just add this one, and this is equals to exponential. Okay, so what's the difference in these two limit? You can see that this one is the denominator is just plus 1, and this is just the power is plus 1. But both limit are the same, which is exponential. So what can I do? I can say if I want to equate this, I just say let's say m is equals to n plus 1. So I want to change the notation because I don't want this has plus 1. I just change into a single value of a variable m. Okay, so I can say therefore I can say that limit of n plus 1 is just, so limit for 1 over n plus 1 to the power of n when n goes to positive infinity. So replace this with m. So m goes to infinity. So even though let's say this is n plus 1, m equals to n plus 1. So n goes to infinity. So this is also the same thing as m. As m goes to infinity, m also goes to infinity. Okay, that's why I can replace just by infinity, because it doesn't matter if you add 1 or if you add a, because this is goes to infinity. A small value doesn't matter. Tak kisahlah apa ni nilai yang kecil sebab dia punya ni dah ke infinity. Okay, and then replace that 1 plus 1 over m, and then this will be the power of n minus 1. Okay, so m minus 1, apa maksud? This is like a fraction. So this is equals to limit of m goes to infinity, 1 plus 1 over m to the power of m, to the power of m, not n, divided by 1 plus 1 over m to the power of 1. So this is just a division, a fraction. Okay. So you can see that this is to anything to the power of 1 is 1. Anything to the power of 1 is 1. And limit, so this is just the same thing as limit m goes to infinity of 1 plus 1 over m to the power of m. This is equals to e. Okay, let's take another one. Okay, let's take another one. Limit of the next one, which is the power is n plus 1. Limit of 1 plus 1 over n to the power of n plus 1. Okay, so plus meaning it's a multiplication. Okay, so this is meaning limit as m goes to positive infinity. Why I have to limit right here? Okay, 1 plus 1 over n. Okay, and then this is n. This is 1 plus 1 over n to the power of 1. If I don't want to do that, this is also fine. It's the same thing. I just expand this 1 plus 1. So this is just anything to the power of 1 is 1. So this is just 1 plus, no, 1. So this is just e times 1, which is equals to e. Okay, so the limit of those things are the same. Okay, now let's look at the series. I think it's better if we take 5-minute breaks and then we continue for series. Okay, so let's take 5-minute breaks. Resume recording. So, apa nak buat? Seterusnya adalah series. Okay, last time saya dah sebut tentang series. You have two kind of series. Is it arithmetic or is it a geometrical series? Okay, so what is the difference between series and sequence? So if you can see that the series is the sum of the term for the sequence. So if we have the sequence, we have A1, A2, A3 until AN, and then the series is just A1 plus A2 plus A3 plus AN. Okay, and we can use the summation notation. We can use summation notation. We can say this is equals to, so this is the sequence, say AN of 1 until infinity, and this one is summation of starting from 1 to infinity of AN. And then you can have this is equals to sum. So the S, this is called the sum of the series. In some cases, the notation will be as n. Okay, same thing. If you have series, you either have convergent or divergent. So if you take the limit, limit when of Sn equals to plus or minus infinity, you can say that this is a divergent series. Okay, and then such that when you say about convergent, you can say, so the limit, and you take n goes to infinity, the same thing, of the series S of Sn equals to S. So you can say that this is the convergence. And this Sn is called partial sum. Okay, for example, find the sum for, find S, find the value of the summation Sn from 1 to infinity for 1 over n plus 1. Okay, so what we do about this? Mana dia punya ni? So what we do, we just expand this into partial fraction. I think I did this last time, right? I don't remember. Okay, so use partial fraction. So I can say 1 over n plus 1 is equals to 1 over n minus 1 over n plus 1. Okay, so you can do this on your own. And then if you take the partial sum, so S of n, so this is just 1 over, just take from n from 0 to infinity. Okay, so this is just 1 over 1. 1 over 1 is 1. I think I did this last time, but it's okay. We can repeat that. Okay, 1 over 1 is 1 minus 1 over 2. So this is the first term. So this is n equals to 1 plus 1 over 2 minus 1 over 3. So this is the term when n equals to 2 plus 1 over 3 minus 1 over 4. This is n equals to 3 plus something something. And the last term, you can see that this is like plus something plus 1 over n. This is something plus 1 over n. 1 over n minus 1. Okay, and then this is plus 1 over n plus, not plus, it should be minus. Minus 1 over n, n plus 1. So you can see that dia punya apa dia punya term ni satu tolak, one is minus, this one is plus. Okay, and if you look at the next one is minus, another one is plus. So the inner term is cancelled out. The only thing that remain is the first term, the first not the first term, the first apa ni dia punya sebutan ni, and then the last part. Okay, so this is equals to 1 over 1 minus 1 over n plus 1. So this is becomes 0. So the whole thing, this is 0, this is 0, and the inner term is 0, except the last, except on the 1 and then on the last term. Okay, and then you can take the limit of that. So you can take the limit, as n goes to infinity for Sn. This is equals to limit of n goes to infinity for 1 minus 1 over n plus 1. Okay, and this is equals to 1 because this one is 0, and therefore I can say that S equals to 1. Okay. So the series is converged. Okay, let's see another example. You can see another example for, let's say, find the value, the same thing. Find the value for summation of m equal, I don't want to use m, let's use I prefer I. So I equals to 1 until infinity, and 2i minus 1 over 2 to the power of I. So I, in this case, this is not a vector, but it's just iteration number, same thing as n. So I is not the x vector. All right, so let's see this one. Let's say try to rewrite this, the Sn into Sn. So Sn is just the partial sum. I just want to take until n. I just want to take the value. I think I didn't say this is okay. So I just want to take not until infinity, but until n. So Sn, I from 1 to n. Because why? Because this is until the partial sum from 1 to n. Okay, same thing. Did I say? The partial sum, okay, of this value. So I 2i minus 1. So this is I minus 1 over 2 of I. Okay. So expand this. This is equals to, so I equals from 1 to n. Minus 1 meaning that this is a 1 over, I just take this out. This is equals to 1 over 2i times 2i over 2 to the power of 1. Okay, so this is constant. 2 to the power of 1 is constant. So you can just take it outside of the summation notation. So this is equals to 1 over 2 times I from 1 to n. And this one is cancel out. This is just cancel out. So this becomes 1. Okay, so you can rewrite this as n equals to 1/2 of I from 1 until n of 1. Okay, so if you remember from your algebra, so this is equals to 1 over 2 times 1 plus 1 plus 1 plus 1 plus, and the last term is also 1. Okay. How many terms inside this? How many terms? Ada berapa? Ada siapa boleh jawab?
N.
Dia ada I. Yes, I term. Sebab dia 1, 2, dia akan jadi how many term? It will be I term. So this is I many. So this is the same thing as not I, sorry, it will be go to N term, because start from 1 until N. So this is N many. So dia ada N many. So it will be 1 over 2 times N. So my partial sum is 1 over 2 times N. So this is N over 2. Okay, so if I take the limit, as N goes to infinity, for Sn, this is equals to infinity. So in this case, this one is diverges. So the series is diverges, positive infinity. Okay, what happened? Also the same thing for, so this is converge. Converge meaning that you go, the limit of the partial sum goes to some value. If it goes to positive infinity or negative infinity, it will be a divergent series. Same thing. We can also have something like the oscillating sequence. We can also have something oscillating series. Okay, let's see this one example. For sequence, if we have -1 and to the power of n minus 1. Okay. So in our sequence lesson, we know that this value, this sequence is a diverging sequence. Why? Because the value is the limit as n goes to infinity for an is alternating between -1 and +1. So let's see the behavior for the series. Okay, so n start from 1 until infinity. N start from 1 until infinity. Okay. Because I don't want to use n, I don't want to be confused. You get confused. Let's use I. Let's use I, and then this is n. Okay. So how about let's look at Sn. Okay, so kalau kita tengok dia punya Sn, so starting from I equals to 1 until n for 1 minus 1 to the power of I minus 1, you can see that this I start from 1. If I start from 1, it will be positive, and then the first term is negative, and the plus, minus, plus, minus, plus, minus, and so on. So you can see that the sum, let's use the, if let's say if I is odd, or let's not use I, let's use n, because that's the ending term. If n is odd, if n is odd, meaning that let's say n is 1, okay, so when n is 1, you can see that this is S1 is equals to 1. Okay, why? Let's say because let's say 1, 3, 5, 7, 9, and so on. So what happened? Let's look at this one. So -1 times 1 minus 1 plus -1 times 3 minus 1 plus -1 times apa dia? Times 3 and 5 minus 1. Okay. And then the series is just this is 0, this is 1, not 0. Why did I say 0? So 1, 1 plus 1 and so on. Okay, and if I have 2, 4, 6, 8, so this is n is even. So n is even. So if n is even, meaning that I have -1, 2 minus 1 plus -1 times 3 and 3, or 4 minus 1, okay, and plus and so on. Okay, so this is -1, this is -1, minus and minus. Okay, you can see that if you add up, so add up the sequence. So -1, mungkin awak tertanya-tanya apa yang saya nak buat ni kan. Okay, so this is Sn for odd, and then Sn for even. Okay, so you can see that the sum is the even term plus the odd term. Okay, so let's say if n until 3, the only thing, let's say if I start from 1 until 3, so meaning that I start from 1 until 3, so n is 3. So what happened? You can see that this term plus this term, and then plus this term. So meaning I have 1 plus the second term is -1 plus 1. Okay, so I have 1. Awak faham tak apa yang saya nak try buat ni? Ke ada saya perlukan penjelasan? Ke tak faham langsung sampai awak nak tanya pun tak tahu nak tanya apa? Faham sebab saya nak tengok dia punya term tu. I sampai even number, I sampai odd number. Okay, so sebab tu saya kata if n is odd, maksudnya apa? N odd maksudnya dia start daripada 1, 2, 3 ataupun 1, 2, 3, 4, 5. So dia berhenti sampai odd numbers. Sama juga kalau yang even tu maksudnya saya akan berhenti dekat even numbers. 1, 2, 3, 4 ataupun 1, 2, 3, 4, 5, 6, 7, 8. So 8 tu adalah even numbers. So Sama juga kalau saya buat di sini, this is odd sum, and if I take the even sum, meaning that I start from 1 until 4. Okay, apa maksudnya? So kalau saya buat macam tu, maksudnya saya akan ambil the value right here 1 tambah 2 tambah 3 tambah 4. Okay, so saya akan dapat 1 the first term plus negative 1 the second term plus positive 1 the third term plus minus 1 the fourth term. So this will be 0. So this is S1, S2, not S, this is N, S is the summation. So this is A1, A2, A3, A4. So 1, 2, 3, 4. Start the parable. So my conclusion is that Sn, the summation of this will be 1 if n is even. No, the other one. N is odd. And then it will be 0 if n is even. So the same thing happened for the series. You remember for the sequence, the value is alternating between -1 and 1. So go back -1 and 1. So in sequence, in series, it is also this, the value is now between the summation, the partial summation is between 1 and 0. So you can say that this is also, this does not exist. Limit of Sn does not exist. So it is a little bit different than the sequence. Okay, any questions so far? So kalau untuk cari value ni, saya rasa rasanya tak ada masalah. Cuma awak kena tengok dia punya ni lah, dia punya apa ni, simplification of the term. Okay, let's see, we look at of the convergence of series. Okay, the theorem says that if the series of un converge, then the limit of un equals to 0. Okay, yang ni penting. Yang ni beza dengan, this is different than sequence. Apa beza dengan sequence? Sequence dia kata apa? In sequence, if it's converge, the limit of n goes to infinity of un is equals to n. Then un is the sequence of un is converge. Okay, beza dia awak kena perhatikan. Dia punya un tu. The un, the limit of un, this one goes to 0. And untuk sequence, the limit, the last limit goes to L. The last term goes to some value L. Okay, tapi dalam series, the last term goes to 0. Okay. Alright. Tapi kalau let's say tapi kalau terbalik, adakah itu bermaksudnya, let's say if limit of un goes to 0, can I say the series converge? No. Yang ni sehala saja. So if it's converged, then the limit is 0. But if the limit is 0, it doesn't necessarily converge. Okay, let's see. And you also need to differentiate. Okay, sebab kita ada banyak definition kat sini. You can also the definition, the first one that I said, if you have limit of Sn goes to L. Okay, the partial sum, the limit of the partial sum goes to one value, this is also converge. Yeah, you can see that the difference. The difference is just this is the term, this is the term, and then this one is the partial sum. Okay, let's see some proof. You can do it on your own. Okay, how about what's the relationship between Cauchy sequence? Same thing. If the sequence is not Cauchy sequence, then the series is also is not converge. So it's the same thing for Cauchy sequence. Okay, let's see this one. Let's see an example. Kita ada dalam 10-12 minit example. Let's say determine the convergence, determine the behavior. Determine the behavior of the following series. Okay. Okay, the behavior meaning if it's related to series, okay, so it means that is it converge or diverge. So let's see, the summation of n over n plus 1. Okay, you can see that this is macam yang kita buat kat atas tadi. Mana tadi? Saya rasa dalam topik sequence. Okay. Okay, kalau tengok kat sini, dia punya soalan. Tengok mana tadi? Bukan mana tadi? Kita ada n. Saya rasa dia tak buat. Oh tak ada. Tak ada. Saya macam teringat ada ni. Okay, let's say this one. The series. N over n plus 1. So my last term, un is equals to n over n plus 1. So this is my last term. So let's say until 1 until n. Okay, all I need to check is take the limit. Okay, so if you divide everything, with n, so it will be the limit of n goes to positive infinity, n over n plus 1. So this is equals to 1, but let's just work out on that. So divide everything by n, n over n plus 1 over n. Okay, so this is equals to not 0, that equals to 1. This one equals to 1. So the limit is 1 over 1 plus 1 over n. Right, so this is equals to 1. So you can see that the limit of n goes to infinity of un is equals to 1, not equals to 0. So therefore, the series is divergent. So all you need to see is the last term until n. Okay. Sama juga tadi, please be careful. Please be careful. Yang tadi saya ni tadi un converge, then limit limit is equal to 0. Okay, tetapi walaupun limit dia sama dengan kosong, dia tak semestinya converge. Let me stress that. Let's stress this one. The series un converge if limit n goes to infinity of un equals to 0. Okay, that's one thing. And then if I have limit apa dia, n goes to infinity for un equals to 0. Okay, so I just want to terbalikkan dia punya tu. Does not mean the series un converge. Okay, so that's one thing. Okay, if we have, if limit of n goes to infinity, un not equals to 0. So this is obviously divergent series. So kalau contohnya, kalau if let's say I have, let's look at example. The series of 1 over n. Okay, if you take the limit of n goes to infinity for, let's say, 1 over n, this is equals to 0. Okay, but if you look at the summation, let's use this one, Sn, this is just 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus plus 1 over n. Okay, the series is not this is much bigger than 1. So this is much bigger than 1. It's not less than 1, but it is bigger than 1. Okay, because this one is close to 1. A little bit extra. Okay, you can see that this one is Sn is diverge. You can also see this if you want to see the thing. You can see that 1 over n. If you replace this into a function or something like that, the series doesn't converge, so it's diverge. It goes to a really big value. Okay, another example. Let's say this one. Let's take example of summation of 1 over n squared. Okay, if you take the limit n goes to infinity for 1 over n squared, this is 0. Okay, so this is possibly converge, possibly. Okay, let's look at the sequence. So the sequence is the summation partial sum is equals to what was that? 1 times 1 over, sekejap, masa dah nak habis ni. Okay, 1 over 1 is 1 squared is 1 plus 1 over 4 plus 1 over 2 to the power. Apa dia tadi? This 1. This is 2 and then 3. 3 over 2, this is 9 plus 1 over 16 plus and so on. So the values is what the value is also growing. Same thing as this one, Sn. So this is also diverge. So this is much bigger than 1. So you can see that not the reverse is not true. Okay, any questions so far? So let me write up, just recap what we did just now. Okay, we talk about the convergence and divergence. We talk about the convergence of a sequence as well as the convergence of series. Okay, so for convergence series, if you have limit of n goes to infinity for the partial sum equals to L. And then you also have, this is meaning that this is converge. Converge. Okay. You can also check that the limit n goes to infinity for nth term un equals to 0. Meaning, so this also meaning that. Okay, so if you have limit n goes to infinity un, the nth term is not 0, so the series is divergence, automatically divergence. You don't have to calculate Sn, but the problem will be when the limit is 0, Sn, the limit for Sn does not necessarily goes to a single value. Okay, and you also have the sequence, the convergence of sequence. If the sequence is monotone and then plus bounded, so the series is converge. Otherwise, this is diverge. Okay, apa lagi? And for the whole thing, you need to remember about Cauchy sequence. Okay, so if the series is Cauchy sequence, or if the sequence is Cauchy sequence, so it is automatically converge. So let's say if the statement say the Cauchy sequence is the sequence is a Cauchy sequence, then automatically you understand that this sequence is converge. All right, so that's it for today. So on Friday,